Jim McGregor with TIRIAS Research. We're here at the Intel booth at MWC, and we're seeing a use of the new Xeon6 processors. And I have
Arindam Saha.
Saha from Intel, and he's going to be walking us through the demo. Please go ahead.
Thank you. So here we are showcasing our latest and greatest in the Xeon6 family. It's a Xeon6 system on chip. The word system on chip basically means we are packing a lot of additional functionality on the same chip, along with the CPU cores, all kinds of other accelerators built into the same system on chip package. What we are showcasing here is a media transcode accelerator that is part of this SoC. With that, it's really ideal for live video streaming kind of applications, live video transcoding kind of applications, which is really a major workload on the internet. Right? And a lot of the bandwidth on the internet is really taken by live video. We are getting about 14x, really unprecedented amount of performance per watt improvement by using this transcode accelerator which is built in. The application we are showing, the partnership we have done with a company called Peak. It's a CDN, among other things, they do a CDN kind of product, a content delivery network. So content delivery network is really that server node that's feeding all the live video content, all the hundreds of thousands of clients that are consuming that video, right? So here in this diagram, the dotted line shows the new Intel Xeon6 system on chip, right? So typically, the content comes in from an origin node, and you would have many different video streams coming in because you're trying to feed all kinds of clients. Right? But in this case, we only bring in one video stream at, let's say, 4K movie, and then for all the other streams that you need, we will do on the fly, in real time, on the chip, transcoding, and use the transcode accelerator for that. So thereby, you're saving a lot of the egress bandwidth coming from the origin node. You don't have to send all the video streams. Now, when we do the transcoding of the video, here I'm doing 10 different transcodes at 5 different resolutions with and without subtitles. Okay? But when we are doing that transcoding, which is a very compute-intensive task, we're not doing it on the CPU core. We can, but instead we are doing it on the integrated media accelerator, and thereby we are saving about 20 CPU cores. Now that you've saved these 20 CPU cores, it's unlimited possibilities of what kind of other services you can enable on the same system on chip. The service that we're showing here is an AI service, and it's basically on the fly transcription from voice to text, and on the fly translation from text to text, one language to another. And all that is being done on the CPU core using the advanced matrix extensions instructions that we have built in the CPU core. So the demo that I'm showing here is on the right hand side you see the video in 4K with subtitles. On the left hand side the video is without the subtitles. Now let's say I'll say, okay, on the fly I want subtitles. Now on the left hand side I just go in there and say, give me English captions. Now that we're talking, you can see on the left-hand side video, in real time, we are doing the speech-to-text translation using the Whisper open-source AI model, utilizing the AMX instructions of our CPU cores, and creating the subtitles in a personalized manner on the left-hand side on the fly. Now let's say you're saying, I don't want English subtitles, I want a different language subtitle. We can do that also on the fly. All we have to say here is, hey, give me French subtitles. Remember, previously on the left-hand side there were no subtitles, and now on the left-hand side we are using the AMX instructions on the CPU cores to, in real time, generate French subtitles. This is one way of showing how you can personalize the content for the audience that is targeted for. There are other kinds of things you can do. You can do targeted ad insertion. You can do interactive applications like cloud gaming, which are low latency applications, that kind of thing. All of that can be done on the CPU core without the necessity of additional AI acceleration hardware. In the system on chip, you also have built-in Intel Ethernet up to 200 gigabits per second. So for a CDN node, one of the key things is how much of bandwidth can I drive egress-wise outside, right? So we are using the integrated Ethernet. We are driving 200 gigabits per second sustained bandwidth, and we are running a benchmark here. Basically, what that's doing is it's generating demand, and it's generating demand by asking for TCP connections. So we can now feed 100,000 TCP connections, which roughly translates to about, because there are 3 TCP connections per client, roughly 100,000 divided by 3, or 33,000 streams are being fed using the integrated Ethernet of this system on chip. And last but not least, on this integrated Ethernet, we also have security capabilities built in. So for example, if somebody is trying to do Nmap scanning of your server, it's basically a rogue IP address coming in and trying to figure out the capabilities of your server. We want to block that. And we can block that in the Ethernet itself without going to the application. We can block it right at the Ethernet level. Another thing we can do, and there's a demo we have here, is anti-piracy. Right? So I'm going to load a different video. So when you load it, you get a token, and that gives you the credentials to play that video. But it's only for you. Now let's say I'm going to show a dashboard here, but in a minute you will see. So let's say I want to share that token, and that is not allowed. The content provider has given you the token based on your credentials and just for you to play. But what I try to do is I'm trying to share it with my friends, or even trying to play it on different devices than the devices it was meant for. And that's really kind of pirating the video, right? So in a moment you will see that we are actually looking for that token that is being shared, and we will block the token. In this dashboard, you will see that one token will get blocked. This particular token will get blocked, and in a minute, there it is. So the token has been blocked. Basically what that means is, hey, you cannot share this video, and in a minute, you see the video has been paused. You cannot play the video anymore. And this capability is built in this integrated Ethernet that we have as part of the SoC. You don't need any additional hardware for the security feature.
I'm sure Netflix loves that, but as a user, I don't.
That's right. It's really for the content provider. Yes.
But I just want to clarify something, because you said without the need for AI acceleration. I want to make sure that people understand that the SoC does include AI acceleration on chip and transcoder acceleration on the chip, so it provides all that. So theoretically, how many different streams could a single Xeon SoC handle?
So here we are doing 10 different transcodes from one video, and when we are doing that, a lot of headroom is still left over. So we can do at least 20 different transcodes of the video. This is going from 4K to any other resolution. So we can do 20 4K kind of transcode on the same chip. That's at the input side, right? On the output side, when you're feeding the clients, here I'm showing 33,000 streams, which translates to about 200 gigabits per second of Ethernet bandwidth that you can do on the single server just by using the integrated Ethernet. Now, while we're doing it, the CPU utilization is still very low. So if I now connect external Ethernet in addition to that, I can go all the way maybe to terabit per second of egress bandwidth coming out of this one server.
That's amazing. That's amazing. And then you imagine 2B servers with maybe 20, 30 per rack. I mean, you're talking millions that you can handle in a single rack. So that's incredible. Thank you so much. I really appreciate that.
Thank you.